Hello, algebra students. Here's the practice test key. All right, number 1 and number 2 are a little bit different than what we did most of the chapter. This is the first thing we learned, where we are asked to take our x and y, they're proposing a possible solution here for our system. We're supposed to put them in to the equations and see if they work. So I'm going to take the first equation here, the y equals 2x plus 7. So I have y equals 2x plus 7, and in place of x I'm going to put negative 1. And in place of y I'm going to put 5. I'm going to see if it makes a true statement. 2 times negative 1 is negative 2 plus 7. Negative 2 plus 7 is 5. So it works. It made a true statement. So far we're good. It's got to work in both equations. It has worked in the first one. Let's try it in the second one now. That's y equals x plus 6. So we take this x and y value. So y is 5 and x is negative 1. So we put them in and do the math. Negative 1 plus 6 is 5. And again, it made a true statement. 5 equals 5. So we would say, yes, that is the solution for that system. All right. Now we have this one here. They proposed, again, a new x and y value, ordered pair, as our solution to this system. So let's plug these in and see. So we start with the first equation, y equals x plus 4. All right, and I have an x of 5, so I'm going to put 5. And I have a y of 1. And you can see that y equals 9. So already, since it did not work in the first equation, I don't even have to check the second equation, which does work in. If I get one that it doesn't work in, I'm done. And that is not the solution for that system of equations. All right, so if they give you an ordered pair and a system of equations, and they want you to check the ordered pair to see if it is the correct solution, this is how you do it. And you have an example here of one where it works and one where it doesn't. All right. Graphing, solving by graphing. Okay, here both of these equations are in slope-intercept form, and they want us to solve it by graphing. And so we have to remember what these various parts are. This is the y-intercept, the number at the end. That's where my starting point. So I have 2 on the y-axis. It's the y-intercept. Now, the slope is always the number in front of x. Now, there's no number in front of x, which means that 1 is that number in front of x. So I'm up 1, 1 to the right. It's 1 over 1 as such. And then use a straight edge to make a nice line, and I'll do my best on this. It's not as easy on the computer, but there it is. And now I have the other equation, which is y equals negative 2x plus 2. And again, I look here and I see that the y-intercept is 2. Okay, well, that's a dead giveaway. Already they're sharing a point, so we know that's got to be the solution to our system. But let's go ahead and graph it anyway so we can see the whole line. So negative 2 over 1. If there's no number under your number, it's a 1. Remember, for negative slope, we go down 2 and then 1 to the right. Here for negative 2 over 1. Down 2 and 1 to the right. Down 2 and 1 to the right. And you can see. There it is. You can see our point of intersection. That's the solution to the system right there, where 0, 2 is. So 0, 2 is the solution to that system. Of course, you can see that that would make true statements in this also. You don't have to do this, but just so you can tie it in there. If I put in 0 for x here, that would be 0 plus 2. Does that equal 2? Yes, it does. If I put in 0 for x here, negative 2 times 0 is 0, plus 2 is 2, and y is supposed to equal 2. So it works. Okay, so that's the first one. Now, we got a little bit of a problem with the second one. We can graph this equation, y equals x minus 3, just like we did the others, remembering that's the y-intercept. That gives us a starting point. Some of you are still grabbing onto that very slowly. Negative 3 on the y-axis. That's what the number at the end says when we have it in slope-intercept form, y equals mx plus b. All right, and what is the slope? Well, again, it's positive 1. There's no number in front of the x, so it's up 1, 1 to the right. Up 1, 1 to the right. Up 1, 1 to the right. There you have it. So we've got one of our lines graphed. Now, we got a little problem with the second equation. Look at this. See how all three equations we've dealt with so far and that we've graphed are solved for y, but not this one. So we have got to first solve it for y, so we can graph it in slope-intercept form. So here we go. I want y by itself over here. I'm going to move that x over, so when we're moving it, we do this. So y equals, and remember, normally you'd put negative 1 minus x. We're going to put negative x minus 1 because we like the x term to come first. It's the same value. Okay. Again, negative 1 is the y-intercept. So there we are. Negative 1. Start our line there. And this time our slope is not positive 1, but negative 1. So I'm down 1, 1 to the right. Down 1, 1 to the right. Down 1, 1 to the right. And then we're making our line. You can see where they intersect each other right there. At 1, negative 2. And again, if we substituted 1 for x and negative 2 for y, we would have two true statements up here for number 4. Anytime we're solving a system, this is really what we're trying to find, the one point they have in common, the x, y value that they have in common that works for both of them. And that is the point of intersection on the graph here. 1, negative 2. Okay, that's the first page. We'll see you for the second page.